Today's video is going to be about logarithmic equations. We've talked a lot about logarithms, but now we're adding in an equal sign. And today we are going to solve those. Here are the steps to solve a logarithmic equation whenever they are log equals log form. And we're going to look at the other type in a minute. But first you want to condense each logarithm, then you want to use what's called the one-to-one property. And that just says that if log base b of m equals log base b of n, then m must equal n. Then we want to solve and check for extraneous solutions. Well, in logarithms, extraneous solutions are when we have log base b of a has to be greater than 0. Cannot be 0 and cannot be negative. So you cannot take the logarithm of a negative number or of 0. So let's follow these steps. First, we're going to condense each logarithm. Well, we already have one logarithm equals one logarithm, so that's done for us. Then the one-to-one property says since we have common bases that these have to equal each other. So we're going to have 5x plus 9 equals 6x. Then we will solve for x. And in this one, we are going to get 9 equals x. Once we have that, we have to check that each of these is greater than 0. So if we have 5 times 9 plus 9, is that greater than 0? Yes. And then if we have 6 times 9, is that greater than 0? Yes. So that means that this solution works, and that is our answer. Let's also look at number 3 together. Again, condense each logarithm. We already have a 1 log equals 1 log, so that's done. So then we will use the one-to-one property. That says that 6 minus 3w has to equal negative 2w. Then we want to solve for w, and that's going to give us that w is equal to 6. Now we have to test each of these. So 6 minus 3 times 6, is that greater than 0? No, because 6 minus 18 is negative 12. So that means that this is an extraneous solution. And since there are no other solutions, our answer is that there is no solution. We'll do one more of these type together. So we first need to condense each logarithm. On the left side, we have this 3 on the outside. So we need to make it an exponent so that there's just a plain old logarithm here. So we're going to have log base 7 of 4 to the 3rd power is equal to log base 7 of 4a minus 8. Now we know that 4 to the 3rd power has to equal 4a minus 8. So 4 to the 3rd power is actually equal to 64. And then we're going to try to solve for a. And we should get that a is equal to 18. Then we have to check both of our logarithms. This one doesn't have a variable in it, so it doesn't matter. But here we have 4 times 18 minus 8. Is that greater than 0? Yes, it is. So that means that a equals 18 is our solution. And now is when we're going to look at type 2, where log is equal to a number. And the way that we solve these is to first condense and isolate the log, then write the equation in exponential form, and then solve and check for extraneous solutions. So we have log base 2 of x minus 4 equals 6. So it's already condensed, and the log function is this part. And we've already isolated the logarithm. So then we want to write the equation in exponential form, and I put the reminder up here of how to translate that. but that's going to be 2 to the 6th power equals x minus 4. And 2 to the 6th power is 64 is equal to x minus 4. So then we add 4 to both sides, and we're going to get 68 equals x. Once again, we want to make sure that we don't have any zero or negative numbers. And we ask ourselves, is this greater than 0? Yes, it is. So this is our answer. All right, number 13, condense and isolate the logarithm. So we want to get one logarithm. Addition translates to multiplication. So we're going to have log of 2x times x minus 5 equals 2. So then let's go ahead and simplify that inside. 2x squared minus 10x equals 2. And now we have one logarithm, so we can have, remember that this is base 10. It's always understood to be base 10. So we have 10 squared equals 2x squared minus 10x. And anytime we have something, we have an x squared, that means we're going to have a quadratic function, and we're going to have to solve it like a quadratic function. So this is going to simplify to 100 equals 2x squared minus 10x. Then in quadratics, we want it to equal 0. So we have 0 equals 2x squared minus 10x minus 100. I'm going to divide everything by 2 to get 0 equals x squared minus 5x minus 50. Then we can factor pretty easily. We're going to get x minus 10 times x plus 5. Then we set each factor equal to 0. And we're going to get x equals 10 and x equals negative 5. Then we have to test each one. So we have a 2x and an x minus 5 to put them in. So for 2 times 10, that is a positive number. And then for 10 minus 5, that's also a positive number. So x equals 10 will work. Now for x equals negative 5, 2 times negative 5, that's a negative number. So this is an extraneous solution. And our only solution then is x equals 10. So that is all for today's video. Go ahead and try the rest of the problems on your own. I hope you have a wonderful day.